Okay, number 4. ABCD is a rhombus with sides 10.5 centimeter. ABCD is a rhombus. Giving ABCD a rhombus with sides 10 centimeter, 10.5 centimeter. If the length of the diagonal AC is 15.8 cm, okay, so AC is 15.8 cm. Using the cosine formula, calculate the length of the diagonal BD, okay, to get BD and B, angles of the rhombus to the nearest degree. Angles of the rhombus. Okay? So solution, let's try and sketch this here. Now if we have ABCD, a rhombus is quite similar to a square. The only difference is that this is a tilted square or a pushed square, a slanted square. Okay? And you know one of the properties of a square is that all the sides of a square are equal. So definitely all the sides of a rhombus are also equal. Okay? Then let's label it A, B, C, D. Please, when you're labeling, make sure you go either you go clockwise, like this: A, B, A to B, B to C, C to D, and A to D, or you go anti-clockwise. Okay, like this: A, and this will be your B in this case. This will be your C, and then this will be your D. Then D will join back to A. Okay, don't just name anyhow, please. Don't name A here and then jump here and say B. No, you name using clockwise or anti-clockwise movements. Okay, what else were we given? AC is 15.8. What is AC? AC is a diagonal. Okay, it's the line that joins A to C. AC is what? 15.8 cm. Now I want to get BD. What is BD? BD is this line here. The line that joins B to D is a diagonal. Okay, so now please, we need to know some properties of a rhombus. Okay, one of the properties of a rhombus is that the diagonals bisect the angles. These diagonals, like this, it bisects these angles. That means it will cut this angle into two equal parts. Cut two equal parts, two equal parts, two equal parts. To bisect means to divide a line or anything or an angle, anything you are giving, into two equal parts. That's bisect. Then diagonals are perpendicular bisectors of each other. These are the diagonals. They are bisectors of each other. It means that they divide themselves equally. These diagonals divide themselves equally. Let's call this point of intersection K. So that means this is where they will divide themselves, and they are what? Perpendicular bisectors. In other words, where they bisect, where they cut each other, where they divide themselves is 90 degrees. So this is 90 here. 90 is also here. This is also 90, and this point is also what? Is also 90. So when you know that, it's a good step. So let's move forward. So we want to get BD, to get the length of BD. That's the length of this diagonal. Okay. Now, from what I can see, we can use the Pythagoras theorem first to obtain some sides. Okay. Look at this triangle now. Triangle BDC. Triangle BDC. We can see from triangle BDC, this is a right angle triangle because these diagonals bisect themselves perpendicularly. So this is a right angle triangle. This is the longest side, the hypotenuse. Then this side, I can get this side. Since they are perpendicular, since they are bisectors, it means that these lines will divide themselves into two equal parts. So let me call this one KC. From this K here to C. Sorry, the diagram is getting rougher now. KC now is equal to what? 15.8 cm divided by 2. which is what, 7.9. So that means I will have 7.9 here, and I will have 7.9 here. When you sum both of them, you'll be getting 15.8. Okay? So since this is a right angle triangle, I can use Pythagoras theorem to solve it. Using Pythagoras theorem. Okay, now one states that what the hypotenuse square is equal to what? Opposite square plus what? Adjacent square. Let's assume, this is the side I'm looking for, BK. Okay, I want to get BK. Okay, to get this BK now, let me call it the opposite. Or let me call it adjacent. Anyhow, I don't know. It's the angle that will tell me which is opposite or adjacent. In this case, I don't know. So I'm just assuming. So hypotenuse square minus opposite square equals to what? ADJ square. So to get this adjacent now, this one, I'm using this one as the adjacent. Okay, so the hypotenuse square, that's 10.5 square, minus, I'm using this one as the opposite, 7.9 square, equals what? ADJ square. So that means the ADJ itself, take the square root of both sides, will be equal to what? Square root of what? 10.5 square minus 7.9 square. When you do the arithmetic, you get the ATJ as what? 6.92 cm. So that means BK 6.92 cm. But this is just BK here. This is just BK. To get BD, which is the whole of this, you need to multiply BK by 2 since it is divided into 2. So BK times 2 equals to what? 6.92 times 2, giving me what? 13.84 centimeter. Okay, so the diagonal BD is 13.84 centimeter. I can't remember if they told us to do it to the nearest centimeter. If it's to the nearest centimeter, that was 14 centimeter to nearest cm. Okay, the B part, the angles of the rhombus. To get the angles of the rhombus. Okay, so let's assume we want to get this angle here now. We want to get this angle. One way you could have done this is to use SOHCAHTOA. Since you already know the three sides, we've gotten this one now as 6.92. So you can use any of the three trigonometric identities to get this. But we are explicitly told, and when you get this angle, what do? You multiply by 2 to get the whole of this angle. But we're told to use the cosine rule, so we're going to be sticking with that. Okay. So now to get this angle, you can see this side is given, this side is given, and this third side is what is also given. So from triangle ABC, using the cosine rule, when three sides are given, and we want to get the angle. So the angle here that we're looking for is this angle B. Okay, so we'll be having angle B is equal to what? Cos inverse of what? A square plus C square minus B square over what? 2AC. So cos inverse of 10 square, 10.5 square plus 10.5 square minus 15.8 square, everything divided by what? 2 times 10.5 times 10.5. So the answer was 97.6 degree, which is what? 98 degree to the nearest degree. Okay? 98 degree to nearest degree. If this is 98 degree, it follows that this one too will be what? 98 degree. Why? You see, this side, can you see this side? This is 10.5, this is 10.5, and this is what? 15.8. It's the same thing that this triangle ADC also follows. This side is 10.5, 10.5, 15.8. If you put inside this formula, you put cos inverse. You want to do the cos inverse of, you will still get the same thing because the sides are exactly the same. So angle B equals to what? Angle D. Both of them 98 degree. Then we need to get angle A. Any of angle A or angle C, you're also going to get the same answer. So for angle A, from triangle ADB, because that's the triangle it is, ADB, this triangle here, okay? So from triangle ADB, using the cosine formula, we have cos inverse of what? B square plus D square minus A square over what? 2BD. You put in the right figures for this, okay? This will be B 10.5, this one is also what? 10.5. Put in the right values, and then you will get what I'm trying to say. Okay, so you have, when you punch it, you have what? 82.45 degree, which is what? Approximately 82 degree to the nearest degree. So therefore, the angles of the rhombus are what? Yeah. What did we get first? 98 degree and 82 degree twice. Okay, so that's that about that. This angle here is going to be equal to this angle C here. Angle A equals angle C. That's what? 82 degree. Because the same 10.5 here, the same 10.5 here, and the same base you'll be using to calculate, which is what? What did we get as our base? 13.84 or 14 centimeter is what you'll be using. So angle A is equal to angle C. We're done with that. Let's move quickly to number 5. Number 5. In triangle PQR, okay? Given triangle PQR, the ratio of the side P to the side Q to the side R is what? Root 3 to 1 to 1. To find the ratio of P to Q to R in its simplest form. Okay? This is quite easy. Let's try and sketch the diagram first so that we understand what I'm trying to do. So now we have something like this. From the question, we have P, Q, R. Okay? P root 3. This is the side that corresponds to P. Side that corresponds to Q is here 1, and this is 1. Oh, it's even an isosceles triangle. Two sides are equal. Okay? To find the ratio of P to Q to R. Okay? So first, let's just get one of these angles. Let's get Q. For example, let's say we want to get Q. Let's find Q. You know, what we're told to do is to find the ratio of the angles. We don't even know any of the angle. It's only the 3 sides we're given. We use cosine rule to get at least one angle. So Q is what? Cos inverse of what? P square plus Q square, all that. I mean P square plus R square minus Q square, you understand? Okay, so I'm just going to put the values quickly because our time is fast spent. Over what? 2 times 1 times 1. So Q is equal to what? When you put this inside the calculator, you have what? 120 degree. Now, if Q is 120 degree, remember the ratio is in the ratio 3 to 1 to 1. Okay, so what? Oh, and you know, sorry, I'm solving for P. Sorry, this should not be solving for P. So to find P, so P is what? P is what? P is equal to 120 degree. Now, if P is 120 degree from the question, P to Q to R is root 3, 1, and 1. And you know, sorry, this was the angle we're looking for before, not this one. So this one is what? 120 degree. Then since this is this side is 1 centimeter, this one is also 1 centimeter. It follows that this is an isosceles triangle, and this one is what, 60 degree, and this one is also what, 60, sorry, would it be 60? It follows that these two angles will be equal, okay? So this will be what, 30 degree, and this is also what, 30 degree. So that the sum of the angles will make up what, 180 degree. Then the ratio of the angles, what's going to be the ratio of the angles? P to Q to R will be equal to what? 120 to 30 to 30. And that will be equal to what? 4:1:1. So this is the answer for this. Okay. Now let's see what we can do again. Our time is far spent. What do we do? Okay, 2.3, solution of plane shapes combining the sine and the cosine rule application. Okay, so now I want to see where we combine from the last two subtopics. We've been solving questions that involve only sine rule or only cosine rule, but now how do we apply both of them together? There is a notice here, the sine rule is easier to apply than the cosine rule. So try to use it first if possible. When solving, it is advisable to use the cosine rule once and then use the sine rule to complement the cosine rule. Okay, you can read that and understand what it's trying to say. So let's move to combined applications. So let's look at the combined applications. Number 1, in triangle ABC, B is equal to what? 42 cm, C is 7.5 cm, and A is what? 48.6. To solve the triangle completely. When they to solve the triangle completely, they are asking you to do what? To find all the remaining sides and the angles that were not solved. Okay, so let's sketch this on a new page. Please, I will be rushing as much as possible. Sorry, I'll be rushing as much as possible. Okay, now triangle ABC. B is 42 cm, C 7.5 cm, and A 48.6 degree. Okay, something like this now. There's no way you can use sine rule first. You still need to use your cosine rule first. Okay, you can see two sides given, opposite angle given. So let's get which of the angles should we get first? Let's get side A first. Okay, to get A, the side here, let's get that first. Okay, we use A squared equals B squared plus C squared minus 2BC cos A. Okay, so A is equal to the root of 4.2 squared plus 7.5 squared minus 2 times 4.2 times 7.5 times cos 48.6 degree. When you punch that into your calculator, so this is still under the root though, you will get what? 5.68 centimeter as the answer. So we've got inside A. So now let's get other angles now. So to get angle B, let's use the cosine rule now. We can use the sine rule now. We've gotten this one A. Let me remove this question mark. We've gotten A as 5.68. Okay, so we can use the cosine rule now to get this angle and the sine rule to get this angle B and angle C. To get angle B, okay, B over sine B, because we're looking for an angle, so B must be included, equals what? The one whose side and whose angle is given. That's A over sine A. So 4.2 over sine B equals 5.68 over sine over sine 48.6. When you solve this, you get what? B, I'm rushing because of our time, B is equal to what? 33.69 degree. So to get angle C, they'll subtract your answers from 180. 180 degree minus what? 33.69 degree plus 48.6 degree, giving me what? 97.71 degree. Okay, so because of our time, there are some solutions I will not be writing explicitly here. Okay, I will just write the formula down and then I'll just put out the answers. If you have been following this video by now, you should know how those answers come into play. Okay, now let's quickly look at number 2. So we've solved that triangle completely. When they say completely, they told us to get the unknown side, the sides that we're not given. Okay. FGHI is a trapezium with dimensions as shown in the diagram below. Okay, I will need to transfer this diagram again. But let's just put this one first. Okay, we have 12 I, H, G, F, 7, 6, 8. If P is a point on IH, P is a point on IH. Okay, I would have loved to be drawing and explaining this at the same time. P is a point on IH. Okay, let me just be doing this small. P is a point on IH such that PI equals to GF. PI equals to GF. Okay. Okay. PI is GF. Okay, let me write it down. P is a point on IH. PI is equal to GF. Calculate angle GHP diagonal GI angle GFI, area of FGPI, area of the shape. Don't worry, I'll explain all this. I'm just trying to compile the things down. Area of shape, IFGH. Okay, let's go and sketch this. Okay, so this was the trapezium that was given. I, H, G, F. This was 12 centimeter and this 8 centimeter. Here we're given 7 and 6 centimeter. Okay, so now we're told to do what? To find. Now they said P is a point on IH. That means P, this is IH. This is IH here. If P is a point on IH, let's say P is here. Let me call it P here. Okay. Then they said PI is equal to GF. That means this place to this place is equal to this place to this place. So let me put equality. You look at FGF or FG. GF equal to what? PI. Okay, PI is a point on IH. PI is equal to GF. That means PI is equal to what? 8 centimeter. So I should have put this here. Okay. So this is symbol for parallelism, that these two lines are parallel to each other. So these are point P, and they said PI here, this PI is equal to GH. That means this part is what? 8 centimeter, and this part will be what? 4 centimeter. So PH, let me take this one up. This was the initial thing. IH was 12 centimeter, but now they splitted it for us. They said from a point P on the line of IH that PI is equal to GF, and GF is 8 centimeter. So that means this one is 8 centimeter. And if this is 8 centimeter out of 12 centimeter, what is left? 4 centimeter. So it follows that this other side is what? 4 centimeter. Okay, let's move on. So first thing, get angle GHP. GHP. This angle G to H, H to P. So we are looking for this angle here. Okay, and how are you going to get this angle? I would advise, I've told you, when you see complex shapes like this, or when you see shapes like this, you have to make instances of a triangle if you can. Okay, let me join P to G. Joining P to G now, you can see this is a triangle. GPH is a triangle. Okay, and on this other side, I have another shape. Since these two lines are parallel, see, listen, these two lines are parallel to each other. Okay, let's just go on first. Let's first of all find GPH. But what you should know is these two lines are, IP is parallel to FG. So it means, and you can see that IP is equal to what? FG, 8 centimeter. This is a parallelogram. You should know that. Parallelogram. Okay. PG. Sorry. I think there is something. Did I miss something? Let me go back to the diagram. Okay, I did not miss anything. So we are told to find what? To find angle GHP. Okay. So how do I go about this? We're going to be using the cosine rule. If you see GHP, this is the angle here, the one I'm shading. H, this is what we're looking for. This side is given, this side is given, but no angle is given. But then we can know this side. PG from triangle GPH. GP is equal to what? IF. Okay, you can see IF here is 7 centimeter. That means this one will be what? 7 centimeter. Why? Because it's a parallelogram. How do I know it's a parallelogram? These two parallel lines, number one, and then the opposite sides are equal. If two opposite sides can be equal, then it follows that the other opposite sides too will be equal to each other. Okay, so you should know these properties for the shapes. Is a parallelogram, and parallelogram, opposite sides are parallel to each other, and opposite sides are what? Equal to each other. Okay, so now we will use the cosine rule. Okay, 3 sides are given now. We have 4 centimeter here. We got 4. 12 minus 8, we got 4. We have 6. 6 was given to us in the question. This 7, we derived it from this corner. Okay, so cos H since we are looking for h, equals what? P square plus g square minus h square over 2pg. So h will now be equal to what? Cos inverse of c square plus 4 square. I said I shouldn't be writing all this again, but maybe I'll just do this for the last time. So when you punch that in your calculator, you get h equals what? 86.4 degree. So we've answered question 1. The B question says calculate GI. To find GI. Okay, what is GI? This is G, this is I. So that means GI is a line, a diagonal, GI, a line that joins G and I together. Okay, so we want to get this side. Okay, and how do I do that? Okay, for me to do that, at least I will need an angle in between here. I have this side, I have this side, I have this side, I have this side. At least I need an angle in between here to enable me to solve. Okay, and how am I going to get an angle? It's going to be difficult, so I think the easiest way for me, you might find an easier way, but the one that is coming to my mind quicker is for me to find another angle here. Let me find angle P. Let me find this angle. Okay, so find angle P. If I find angle P in this corner, if I'm able to get P from here, then I'll be able to get this angle. I will just use sum of angles on a straight line. You get? So let me get this angle. But before there's no way I can get. It's difficult for me to get this angle now. Okay, it's not even difficult. I already know h. I can use the sine rule. So h over sine h. Why am I using h? Because I know the angle and I know the side. Equal to then the angle I'm looking for itself. That's p over what? Sine p. And that's equal to 7 over sine 86.4. We just got this angle now, h as 86.4 equals to what? 6p. This is the side that corresponds to p, 6 centimeter over sine p. Is sine p, we're looking for the angle. When you put it into your calculator, you will get angle p equals what? 58.8 degree. So from the diagram, angle GPI equals GPI. That's this angle here. When I say GPI, this one is equal to what? 180 degree minus 58.8 degree, which is equal to what? 1 to 1.2 degree. Which law did I use? Sum of angles on a straight line. Okay, this one plus this one must give me 180. Since I've already gotten this P as what? 58.8 degrees, so I subtract this from 180 to get 1 to 1.2 degree. Okay, so now that I've gotten this, I can now use what they call it, the cosine rule now. Using cosine rule. Cosine rule now, I want to get GI. It is opposite P from triangle. So you see why I was saying that you use the sine and cosine rule to dissect complex shapes, to dissect shapes into triangles. So from triangle what now? Triangle PIG. So from triangle PIG, I want to get P square, which is opposite this. Because that's what I'm looking for. That's GI. P square is equal to GI. So P square equals what? G square plus I square minus 2GI cos P. So P is equal to what? The square root of all this. 8 square. 8 square here. 7 square here. 2 times 8 times 7 times cos 1 to 1.2 degree. So P is equal to what? 13.08 centimeter. Therefore GI is what? 13.1 cm. to the nearest centimeter. Okay, so hope we're getting that. See angle GFI. If I can remember, was that it? Angle GFI. So what is angle GFI? GFI, that's this angle here. Okay, we use the cosine rule. 3 sides are given. This side is given, this side is given, and we just want this side now. So using cosine rule, so it's like as if we're looking for side f, small f here, small f here. Okay, so I have cos inverse of what? G square plus I square minus f square over 2 times g times I, which is what? Cos inverse of what? What's g square? G square is 7 square plus 8 square minus 13.1 square divided by what? 2 times 7 times 8. Just know you should know the formula to use already. I'm looking for this side. I'm looking for this angle rather. This side is given. This side is given. And this side, I've worked this side out. So that's the formula I'm using. When you punch that in your calculator, you get what? 121.2 degrees, something like that. Approximately 121.2 degree. Okay? Your answer here should tally with the answer. Your answer here should tally with the answer that you got here. Okay? Because the opposite angles of a parallelogram are equal. So if this angle is equal, this one must be equal to this one. Okay? So if you are getting something approximate, like in my own case, when I first, my calculator is giving me 121.6 degree now. Okay? But I just have to adjust it to this particular one I got initially, because the two angles cannot be different. Okay, I'm getting this because we've been approximating since morning. All these workings that I've been approximating. That's why the answer is approximately equal, not exactly equal. We're doing approximations, but don't be scared. It's part of math. The area of FGPI. To find area of FGPI. Okay, where is FGPI? FGPI, that's the area of this parallelogram. Okay, area of parallelogram. FGPI. Now, the area of a parallelogram, you can use any of this: base times height or length times width sine theta. You use this one if the height is given and the base is given. You use this one if height is not given, but they gave you the sides. Okay, in this case now, no height is given. No height is given. So we use, but sides were given. So we're going to be using the sides and a corresponding angle. Okay, so let's assume we're using from this side now. We have area of FGPI. 8 times 7. That's this side here. Length, width. Okay, times what? Sine. What's the angle between the sides we're using? Take note of this is the side I'm using this times this. So 8 times 7. Sine what? What was it? Was 121.2 degree. You can also decide to use this side. 7 times 8, you get the same answer and the same degree. Okay, when you punch this in your calculator, you're going to be getting 48 centimeter square. Okay, so the area of that shape is 48 centimeter square. And area of IFGH. What is IFGH? IFGH. That's the area of the whole shape. Okay, and that's going to be what? This is like a trapezium. Normally, a trapezium half open bracket a plus b half open bracket a plus b times height. There's no height in any of this diagram. So we're just going to add the area of this parallelogram with the area of this triangle. Okay? The diagram is looking really rough. Just try to be. We'll add the area of this shape plus the area of this triangle over here. Okay, so let's get the area of triangle GPH. Area of a triangle, you can use either half base times height or half AB sine theta. This one, you use this one if the height is given. You use this one if the height is not given. Here, we don't have any height that is given, but the sides are given, and an angle in between is also given. Okay, so we're going to be using this one. You will see that your segment, the formula for your segment of a circle follows this second formula. Okay, so we're going to be using half times 6 times half AB sine theta, half times 6 times 4 times sine, what's the theta that is in between? This is the theta here, and we worked this one as what? 86.4 degree. Okay, when you punch this in your calculator, you're going to be getting what? 11.97 centimeter. Okay, so 11.9, that's approximate what? 12 centimeter. So the area of the total shape, now what's the area of the total shape? That's area of this parallelogram plus the area of the triangle. Area of parallelogram, we got that's 40 centimeters square. So area of shape, total area of shape will be equal to what? 48 cm square plus 12 cm square, 60 centimeter square. Okay, so that answers all for that question. And then okay, so number five, one side of a rhombus ABCD, so we have rhombus ABCD giving rhombus ABCD. One side of the rhombus is 8 centimeter in length. Okay, if angle DAB is 64 degree, to find BD and AC. Okay, let's push this into our sketch pad. Okay, with all these drawings, in fact that's what has taken most of our time in this tutorial. With all these drawings, I want to believe that you guys by now you should know how to go about the drawing of all these shapes. Okay, a rhombus, we've done something like this before. Let me make it more rhombusic. Okay, so this is A, B, this is C, this is D. If angle DAB 64 degree, DAB is DAB 64 degree. Okay, we want to find what? BD. BD is a line that joins B and D together, so we want to find this. Okay, and what are we going to be? Okay, one side is given as what? 8 centimeters. So that means this is 8, this is 8, this is 8. Why? Because all the sides of the rhombus are what? Are equal. Okay, and then to get angle DAB now, this side is given, angle in between is given, cosine rule should come to your mind straight off. Using the cosine rule, it's as if we're looking for small a here. Small a here is equal to our what is equal to BD. Okay, so a square equals what? B square plus D square minus 2BD cos A. So A square is equal to what? Square root of what? This is your B, this is your D. Okay, this is my B here, small b here, this is my small d here. So 8 square plus 8 square minus 2 times 8 times 8 times cos 64 degree. Okay, so A equals what? 8.48 centimeter, which is what? The same as what? As our BD. Okay, so we've gotten this already. The next thing now, I to get AC. What is AC? AC is another diagonal, the line that joins this one to this other side. Okay, let me use a different so that we don't get, this is AC. Now to get AC, what do we do? What do we do? What do we do? Okay, AC. So I think the best thing to do in this kind of case to get this AC, since we already know this BD, we've gotten it as what? 6.4. We've gotten this one as 8.48 centimeter. Okay, let me erase this now. 8.48 centimeter. So let's get from triangle AB. Let's call this maybe M. Let's call the point of intersection of this place is M. Okay. Now, so from M, you know that the rhombus, the diagonals intersect, they bisect each other at what? At 90 degrees. So that means this is 90 degrees. So let me concentrate on this triangle ABM. Okay, so this triangle ABM. Alright. This side, the longest side, hypotenuse is given as what? 8 centimeter. And I know this side. I can get this side. You know, we've already gotten. Okay, sorry, is this side? I know this side. We've gotten BD. From BD equals to what? 8.48 cm. Then BM. BM is equal to what? BM is 8.48 divided by 2, which is what? 4.24. So that means over here I have 4.24 centimeter. So I have this side and I have this side. So I'm just left to look for this one below here. Okay, so I have to look for this one here in pink. Okay, by Pythagoras theorem. Hypotenuse square equals what? Adjacent square minus opposite square. Okay, so BD equals what? Square root of hypotenuse 8 square minus what? 4.24 square, giving me what? 6.78 centimeter. So that means this part to this part is what? 6.78. But you know, AC is going to be double of AM. What am I doing? This is not BD. Sorry. It's not BD. I'm not doing BD. I'm doing AM. What I was doing is what? AM. This is what I saw for now. AM. I've gotten it as this. So AC now will be equal to what? 2 times AM, which is equal to 2 times 6.78 cm, giving me 13.56 centimeters. Okay, so that's that about that, and that brings us to the end of the first module of this tutorial. Thanks for watching.